Hi, I'm Casey.
Hi, I'm Hannah.
And I'm Sean.
I'll be discussing the contemporary problems with stratospheric aerosols. Geoengineering using stratospheric sulfate aerosols is the hypothetical idea of injecting small particles, known as aerosols, into the stratosphere to block the sun's radiation. By injecting the aerosols into the atmosphere, it would reflect the solar radiation back out into space, cooling the Earth in return. This type of geoengineering has not been put into use yet and is still a theoretical process. This has become a popular idea due to the fact that it is a replica of what volcanoes do, creating aerosols, and in return cooling the Earth, which we will discuss later. Testing this geoengineering process is not an easy task due to the risks of a test turning into the real deal if the affected area becomes too big. Although testing would be tricky, they have many different ideas as to how to approach this process. There have been a few proposed ideas on how to approach the situation. One popular method is sending up a large tethered balloon with a hose attached to a high-pressure pump about 20 kilometers up. Through natural wind patterns, this would then spread the aerosols around the globe. The second proposed idea is flying jets, spraying sulfuric acid, which then turns into sulfate aerosols when combined with water vapor, and then wind patterns spread it across the globe. This will result in aerosols being all across the world, reflecting about 1% of sunlight back into space. This is not very easy theory to test due to the potential of it turning into something more. It has been proposed to test the balloon method, but only in a small area 1 kilometer up. Using this type of geoengineering has many pros and cons. Some of the pros are that it has been proven to work due to natural aerosols such as volcanoes. It will help reverse the ice melt and promote tree growth, and it would be the most effective, timely, and cheapest method, costing about $50 billion a year. The cons, on the other hand, which mostly outweigh the pros, are that it could cause a drought, it could damage the ozone layer, resulting in increased ultraviolet radiation, and that if there was a miscalculation, it could potentially result in another ice age. It could also result in less sunlight reaching the Earth and solar panels giving off less power, telescopes might not work as well from Earth, and it would not stop ocean acidification. Lastly, it is not a process that is easy to stop, and if it is stopped and not cleaned up, it could harm crops, animals, and ecosystems. So clearly, at this point in time, there are many more cons than there are pros of this method. Although there are many bad aspects to man-made aerosols, there are also some natural aerosols such as volcanic eruption and desert dust. Volcanic aerosols accomplish the same goal that we want to. The sulfur dioxide gas converts to sulfuric acid in the stratosphere, spreading across the globe and cooling the Earth. This happened with the eruption of Krakatoa in 1883. Desert dust is picked up after a storm and absorbs and scatters sunlight, letting less light reach the Earth in that specific area. On the other hand, human-made aerosols can hurt the environment, such as burning tropical forests, coal, and oil, and these aerosols can reflect light and in return pollute clouds. Using this method of geoengineering is tricky in more ways than just the physical harms of it. It is a difficult idea to persuade enough people to act on it due to the fear of it harming us. And even if we do decide to follow through, who does it? Who makes the final decision and starts this process? Being aware of this potential method is important so that we don't put power into the wrong hands. We must make our decision as humanity as a whole due to the fact that it will be impacting all of us and our future generations.
It's a bird! It's a plane! No, it's stratospheric sulfate aerosols? Well, not nearly as exciting as you'd initially think, but believe it or not, atmospheric aerosol science has accumulated a rich history throughout the past 2 centuries. Aerosol science begun in the era of Enlightenment. The biggest question posed back then was, what is the origin of atmospheric aerosols? We can now easily conclude that it comes from either natural processes or anthropogenic activity. But back then, the answer was not so simple. Keeping in mind that this was a transition period from theory-driven based science to observation-based science, which makes the Enlightenment an ideal sweet spot for aerosols. The sprawl of smoke, volcanic emissions, and dust aerosols across the atmosphere was thoroughly documented by multiple science communities, one of them being Prestel. The most insightful theories on aerosol formation can be accredited to Constantine, a European polymath. Alongside modern quantitative measurements of aerosol concentrations began with the work of John Atkin, a physicist and meteorologist. Okay, still with me? Now that we've covered a crash course on aerosol history, what really rattled the playing field was volcanic eruptions, Mother Nature's own natural version of aerosols. Flashback to Krakatoa caldera, 1883, now currently known as Indonesia. one of the most epic eruptions to date. In the years following Krakatoa's eruption, weather patterns became chaotic, record rainfalls hit, and temperatures did not return to normal until 1888. That's 5 whole years later. The most interesting result, however, was the sulfuric acid droplets that hung around in the stratosphere. These little particles acted like a giant solar reflection blanket on the Earth. And well, the proof is in the air. The following years showed a decrease in as much as 2.2 degrees Fahrenheit in the global temperature. As we move beyond the 18th and 19th century, Krakatoa acted like a catalyst, enabling scientists further on studying stratospheric aerosols. This is kind of where things get messy. Since then, there's been significant developments in technology significant developments in the field thanks to advancement in technology. We've been able to attempt man-made aerosol strategies, mimicking the idea that we saw with volcanoes. It's actually relatively simple. By putting precursor gases such as sulfur dioxide or hydrogen sulfide in the air, they've proven to be very valid options. Alongside materials such as photovoltaic particles, titanium dioxide, and diamond particles are all alternatives. Some are obviously more abundant than others, but these are all manifestable. But long story short, scientists have been playing a game of guesswork all this time. Almost all the research to date have been limited to modeling and lab work. Economically, sulfate aerosols will be relatively cheap to manufacture, as well as being technologically feasible. We've already been able to develop chemical manufacturing and high-altitude aircrafts for deliverance. So now you're thinking, what's the holdup? The main issue we've seen scientists encounter is the fear for altering our atmosphere permanently and getting a global widespread approval to do so. Our history has shown that Mother Nature has her own ways of combating global warming. So is it really our place to interfere as well? Our aerosol solution? That's the question we need to start answering.
As my partners have acknowledged, stratospheric sulfate aerosols represent a question mark in humanity's future. While the process has the potential to cool the planet and slow the heating of the Earth's atmosphere, it carries with it questions that we cannot easily answer. We've asked whether we can change our planet's climate, but not whether or not we should. Determining who should be responsible for answering these scientific and moral questions is a task I'm not equipped to answer, but I shall try and present some of these questions here for your consideration. In his book, A Case for Climate Engineering, Professor David Keith argues that climate engineering is not only a reasonable pursuit for humans to attempt, but also technologically and economically feasible. Keith is quick to couch this assertion with the reality of almost all climate engineering strategies that manage solar radiation, that they can't solve our problems in the long term. These plans can reduce the effects of climate change, but they do not eliminate the problem itself. And abuse of climate engineering is, to put it lightly, a severe risk for human existence. Changing our habits, both personally and on a societal scale, will be necessary to reverse climate change, and climate engineering is not the magic bullet that lets human society give up on its destructive habits. But before humans even begin to attempt any of this large-scale climate engineering, we must first ask the practical questions that surround the topic. We don't have all the information. We do know these techniques and strategies are supposed to accomplish certain ends, but it is impossible to foresee every outcome and side effect these plans might have if enacted. In a 2008 article in the Bulletin of the Atomic Scientists, Alan Robcock lists 20 reasons climate engineering aimed at reducing solar radiation might be a bad idea. Included is the reduction in sunlight limiting both plants' ability to process CO2 and the reduction of solar power efficiency, not to mention the unbalanced impacts on different regions by these techniques. Can you justify destroying one country's ecosystem to save another country's? Who could impartially decide how much to change the climate, knowing that it would impact the whole world differently? Ethicist Clive Hamilton describes a hypothetical where a country, like the United States, allows a nation with less regulation, like China, to alter the environment freely, not bothering to enforce environmental restrictions when it suits the country's own needs, or even if it's unclear how far they are legally allowed to go to intervene. The biggest issue with climate engineering is who is at liberty to decide if the climate engineering is suitable and safe to use, if it should be used at all. In Christopher Preston's collection of essays titled Engineering the Climate, he begins with that same question, reminding us that we can all claim a legitimate stake in the control of the global thermostat. Not only that, but how do we properly account for those whose voices are so often ignored, like indigenous populations and NGOs? One of the biggest criticisms of the UN's Kyoto Protocol was that disregard for the opinions of groups that are often voiceless, extranational groups, and involving those most at risk of having their lives and livelihoods destroyed, intentionally or otherwise, by climate engineering. Answering these questions is critical if we're going to decide our future. As Professor Tim LeCain of MSU points out in his essay titled Against the Anthropocene, a Neo-Materialist Perspective, treating climate engineering like it can solve our issues even temporarily is a dangerous attitude, and one that allows our damaging behaviors to continue. Injecting sulfate aerosols into the stratosphere could buy humanity the time we need to fix our mistakes. It won't solve anything on its own, but if we're ready to change, it could keep things from becoming worse during that transition. Before we can do any of that, however, we need to be willing to ask the hard questions and be prepared when we don't like the answers. Thank you.